So, the agenda for today. Let's look at the schedule for the next 2 hours that we booked. We will begin with framing and objectives to set the stage, and at 10:20 we will move into the technical overview of the platform. It will be followed up by a live demo, and we will wrap up between 11:15 and 12 by discussing the exploitation roadmap, including our pilot programs and next steps for potential partnerships. I will now take you through the project's overall vision, the technical maturity, and the expected outcomes. First of all, my name is Olga Arsenovic. I'm a project manager at Success, and I'll be guiding you through this first part of the session. So, what is LEONSEGS? It is a European initiative. It's designed to redefine how satellite data is managed and accessed. By creating a federated, automated environment. This is how we aim to lower market entry barriers for new space companies and provide high quality services to all users. This work is made possible by the International Project Consortium. We have GMV as the lead coordinating partner from Spain. We have PLUS leading the semantic search and training, and iStack Space as a new space partner, providing thermal imagery and validating the interfaces, and Success leading the communication, dissemination, and exploitation strategies. So the vision behind LEONSEGS, the gap that we are addressing is market fragmentation. Currently, users face so-called data silos and complex manual workflows, and the solution is to create a federated ground segment as a service. What we're trying to build is a one-stop shop, a single automated interface that combines satellite mission control and automated data processing, all to deliver results much faster. And the overall objectives of LEONSEGS are categorized into 4 key areas. We can talk about scientific and technical aspect, since we're focused on the advanced Earth observation automations, which enables end-to-end processing of complex multi-sensor requests and generally improved user experience through higher quality, through higher availability and lower latency. Then again, the economic aspects. The goal is to reduce the Earth observation service costs and to develop more sustainable, collaborative, so-called new space ecosystem. Then we have the societal aspects and objectives. That means we also aim to promote entrepreneurship based on space assets, support generally the European constellations through more cost-efficient operations. And finally, policy. We want to strengthen EU global leadership by reducing dependency on non-European data and boost the exploitation of EU space assets. So overall, we're creating a path from technological innovation to economical sustainability, all to generally just reinforce the EU strategic autonomy. More specifically, the objectives of the platform and the technical maturity. Current goal is transitioning to so-called technology readiness level 6. This means our technology is being demonstrated in a relevant environment, which is kind of what we're doing here today as well. We want to move beyond the lab and to simulate actual real mission operations and generally just to prove the platform's capability for industry use. So at this session, what we want to achieve, we can say that we have 3 specific goals. We want this so-called validation of fit for purpose. We need to confirm if LEONSEGS addresses real-world challenges like high level of expert knowledge currently needed to order products. We're assessing the one-stop shop value. We want to see how effectively the interface simplifies the the existing requests from users, and the general technical proof of value. We will show you how the semantic search and cloud-free composites solve common industry challenges. So from your side, from the participant side, we're hoping that your role is very vital in this, in shaping the future of the platforms. So we will invite you now and share later on with you this QR code, because we want to invite you to fill in the user validation survey. To share your perspective of your needs, some expectations, maybe some feedback on what you will see during the demonstration. So this survey will be open until May 15th, and then we will, of course, like I said, share with you the link and everything. But just if you want, you can open it now. But please be open to share your feedback. It would be very valuable for all of us. So I will now hand it over to the technical team for a deeper look at the whole architecture. So please take over and present yourself.
Hi, good morning to everybody. I'm Álvaro Núñez. I'm from GMB. I'm the technical lead of the LEONSEGS project, and I want to explain properly what the LEONSEGS platform is, which is specifically for the technical part, and together with my colleagues, how does the system, how actually works. So, what is the LEONSEGS? Is a federated multi-mission Earth observation ground segment service platform. It's a short answer, a very difficult description, but it's a platform designed to first orchestrate different Earth observation services and end user requests. It also, on the other part, federates heterogeneous Earth observation missions and different providers. This is very important, the standardization for this part, and we will focus later on. We also have a part for support the mission operations through ground segment as a service capability. That's the main three objectives for this platform, and that it is designed for it. To achieving this, we have two main system segments differentiated. The first one is the AMIO segment, which is the automated multi-mission Earth observation service. And the other one is the MOCPS, the mission operations, control and processing service. Here you can see the picture of the architecture and the different stakeholders it interacts. You can see the LEONSEGS platform that it consists of these two segments I have just spoken about, which is the AMIOS and the MOCPS. Each of these segments interacts with different stakeholders. For the AMIOS part, the main user, the main client or customer of this segment is the Earth observation end user, which is the people that ask for the Earth observation services we have available, and they consume the Earth observation products we provide. They can need it for whatever reasons they want, for operational, specific, or commercial. In here, it can be a quite broad of stakeholder of customers, like I don't know, agricultural associations or organizations, different institutional organizations, just for the infrastructure, for whatever we can provide as Earth observation services. There are different Earth observation end users that want to request a service. On the other hand, of the endpoint of this platform, we have the Earth observation product provider, meaning here we have two different suppliers of Earth observation data. We are distinguishing two different of suppliers, which are the external catalogs. If the end user wants to request a service uh, with the time from the past that the images are already taken and stored, but in external catalog, for example, we have available the Copernicus catalog for Sentinel-1 and 2 and the Landsat 8 and 9. We have already available that interfaces. But any other satellite operator that already have an established catalog can interface with our system and provide us with the image to at the end to sell their images and our services. And on the other hand, if this is for the past, for request for the past, we have the Earth observation external providers that they are the satellite operators, the Earth observation satellite operators that are already also stabilized, that they are operating and working on their own, but they are federated to the platform, retaining their own capabilities and their own control of the system. But through them, we can ask them to task a specific acquisition that we need to uh, to, um, to give to the end user, to the Earth observation end user at the end. That's the different stakeholders that interact with the AMIOS segment. But on the other hand, we have the mock PS, where the main, go back please, where the main stakeholders is the ground segment as a service end user. Olga, go back please. Yeah, thank you. The ground segment as a segment end user for this segment should be any satellite operator or new space company that wants to externalize their own ground segment operation. And they can use the LEONSEGS platform to that end, meaning that they will not need to set up the infrastructure, the manpower, all the licensing and software costs on developing any kind of ground segment software. So they can externalize all that and focus on launching their own Earth observation satellite and focusing on selling the images. That is the main goal of the company, externalizing all the ground segments through us. And related to this as well, we have the ground station provider, which basically is the the network of the antenna providers and the communication infrastructure that today they are already setting in the worldwide. For example, at this moment we are not planning to have our own antenna. For example, we are going to externalize that services through the different providers that are already available in the market. And for that then is the way to provide for the ground station provider to provide their own services to a broader uh, satellite operators that are connected with our platform. Next, please. Just to focus in each segment. The first one I have talked about is the AMIOS segment, which mainly is the Earth observation oriented segment of the LEONSEGS platform, the system. And as I said, is the main interface with the Earth observation end user. For that end, the main functionalities of this segment is the handling of the Earth observation request that the end users want. We have as well the Earth observation data discovery and catalog access, meaning that this is the search of the products within the catalog that fulfill all the criteria that the end user wants, is requesting. Here, we are within the consortium, we are developing a new way of semantic search for this catalog, for the product search of the catalog that later my colleague is going to talk about more deeply. Other functionality of this segment is the tasking and planning orchestration of the multi-mission, where we can have different source of data that must be handled within the service, the different acquisitions coming from different sources. And this segment as well is processing the raw data coming from the different catalogs and different sources, meaning that if, for example, Sentinel-2 images that provide this level 1 processing image, here in this segment is processed further to generate a new complex product available for the end user. For that end, the characteristics of the segment is, as I said, is multi-mission by design. It must be scalable because different suppliers are going to be connected, different services are going to be created without waiting, without stopping continuously for the future. And it must be automated and easy to understand for the end user. And next, please. Yeah, Martin, I think you can talk about specifically for the semantic algorithms.
Yes, thank you. Thanks a lot. Welcome also from my side. I'm Martin Südmans from the University of Salzburg. I speak on behalf of our team. And as you can imagine, we have to deal with millions of images and even finding the qualified images for a specific task or for a specific request, whether it's a direct image search or an EO service that a user wants to have, is not an easy task anymore. The solution that we provide here or that we develop is semantic search. In short, it focuses on what is actually visible or what is inside the image, what's the content of the image, instead of broad metadata. That's how the current search in the standard catalog works. You have the metadata that are valid for the entire image, for example, the date, the acquisition date, the location. You may also have some cloud cover, but they are generally for the entire image. For example, 80% of clouds means that 80% of the image is cloudy and not necessarily the area that you're actually interested in. So in cases where your study area is larger or smaller of these images, those image-wide statistics, they don't match anymore. And as you can see on the right side, what we do is that we enrich all the images with per pixel semantic information. This is our label about clouds, but also some land cover information, whether it is vegetation, water, and so on and so forth. So this semantic layer is available for each of the images. And on these layers, we do the semantic querying. We can either process our own one or use ones that are already available. For example, the scene classification layer from Sentinel-2, Cent2Core, bottom of atmosphere correction, which are available, we can use as well. And if you can imagine here the area of interest that a user creates, doesn't have to match with the actual image extent. We generate these statistics on the fly to provide the image or to provide the users with the images that they are interested in. On the next slide, you see the a specific implementation of this algorithm in the LEONSEGS platform. We have implemented this in the multi-mission archives from Sentinel-2, Landsat 8 and 9, and Satellogic data. And what you can do, for example, is searching cloud-free images which are closest to a specific date. This could be that at the specific date there are no images acquired, or that they are cloudy, and then you would get the closest one. But again, for cloud free means in our case, cloud free in this specific area of interest that you are interested in. We can also do this for other types of categories. For example, you can search for the most vegetated or the non-vegetated images. Again, for the content-based image search. This is for retrieving the images and either sending it directly to the users or to forward it to the processor. Another example for a semantic algorithm that we implement is a cloud-free composite processor. In contrast to what you have as a cloud-free composite that's pre-generated for a specific area or a specific time frame, our cloud-free composite processor can take any time of or time span of interest that the user selects, and of course any area of interest, and then it will create the cloud-free composite, taking into account the semantics of the pixels. So it will remove all the cloudy pixels and then calculate the cloud-free composite only for the remaining pixels. What is important here that the user also gets some additional information. For example, how many pixels in total contributed to the cloud-free composite, or what you can see these colorful maps on the right side is that you can actually trace back the pixels from which time they come from and where they contributed to the resulting cloud-free composite. This is an overview over the semantic algorithms, and I hand over back to Ivan now.
Thank you, Martin, very much for the complex explanation. Moving on, the other segment is the mock-PS, as I said, which different from the previous one that was the AMIOS. This is the operation-oriented segment of the system, which is the main interface with the ground segment as a service end user. Each segment is oriented for one specific end user for the platform. Then the main functionalities, the core functionalities of this mock-PS are almost the same as any ground segment, any appropriate ground segment must have. Meaning that is the functionalities. One of them is the mission planning and scheduling. That's the planification of the different activities and acquisitions by bases, everything of the satellite and the mission that is federated within the platform, that it uses the platform as ground segment as a service. The other one, the other functionality is the monitoring and control and execution of commands, the reading of telemetry of the satellite. Quite easy. Other is the flight dynamics and collision avoidance for the satellite, for every satellite that is federated and it's using the platform as ground segment. So this segment is the main interaction with the different Earth observation satellites that are federated, and different ground segment and antennas, meaning and different networks of communication infrastructure. It also pre-processes the payload data that is directly downloaded from the satellite, which are federated here. as well. This is the preprocessing, meaning that it goes from raw data from Catus and to level 1 at top, meaning that this is the preprocessing and it can serve as a supplier data, combining different data from this one and from the other suppliers, from external catalogs or other external Earth observation product providers, and processing it further to create the complex product I was talking about in the other segment, in the Amuspack. So, for the mock PS segment, the main characteristic is that this is a ground segment as a service by design, so it must be secure, and it's very important to have a create guidelines of standardization. That in the next slide, my colleague from NISTEC, Eugeni, is going to talk more in detail about.
Hello, thank you, Alvaro. I'm Eugenius, representing ISTEC, and I will be discussing regarding the standardization and its importance within the development of the platform. So the platform has been developing following a findability, accessibility, durability, and the reusability principle. It's really important to take these principles into account when developing the platform to ensure lower integration costs for new user, both current segment user and providers, and to ensure also a scalability of this platform. To do so, we have taken into account different entities, well-known entities, and their standards. So their comparison of new users into the platform, it's suppose the lowest cost possible. So to do so, I will go a bit more into the detail what have been Alvaro and Martin commenting. Starting with the Ameos part, we are splitting for these external catalogs where we are following spatio-temporal assets catalog standard. So these standards have been followed by huge companies as Copernicus or Landsat. So we want to make it as easy as possible, this integration of external catalogs, where the user is requesting the area of interest, time range, and other optional semantical constraints to this request. While on the other side, for the external Earth observation external provider, it is followed a sensor tasking API interference, where it is scheduled also this area of interest, time intervals, and some instrument configuration, which are the ones required by the user. From the other segment, these mock peers that has been discussing now, it has been incorporated a simple schedule format, a specification, so to make it as easy as possible, this interaction, and to incorporate a data storage, which is giving us the possibility of making a pooling of high amount of data without spending that much time. For that reason, we are using this CubeSat space protocol that allow us to reduce the latency and the bandwidth consumption, because at the end, the platform wants to ensure this accessibility and easy incorporation, and also the speed required for the user. Thank you.
Thank you, Evan. The next part is the objective, or let's say the objective of this workshop, that is actually showing you how what we already have, the version we already have of the LEONSEG system. take into account that this is work in progress. We are constantly developing new functionalities and new versions of different subsystems, of new version of the whole system. Next slide. I'm going to give you a bit of context of how we thought that this platform is going to be used, and we have come up with 4 different use cases. Just to give you a bit of context, I'm not going to go too much into details before the live demo. The first use case, that is 100, is the request for archive images. This is thinking that the end user, Earth observation end user, is going to request an Earth observation service from the past, meaning that all the images are already taken, and the platform is going to search for that images. They're going to process it to the service the end user is requesting, and then the platform is going to send this final product to the end user. Quite easy to understand. The second use case is the 200, that is the satellite tasking via ground segment as a service, meaning the whole process is the Earth observation end user is requesting an image, but for the future. And after this request is processed, the system knows that we can take the data we need for that service with a satellite that is already federated within the platform, meaning that it's going to come up with the opportunities for taking that image that we require. It's going to be passed on to the mock-PS segment. This image is going to be planned. The required passes for uploading the schedule, for downloading the image, and for monitoring the satellite are going to be booked. And then this is everything automatically. And then whenever the time arrives, it's going to send the proper commands to the satellite, the schedule. And after that, once the schedule has taken the image, the other way around, the other way back, meaning that the satellite is going to download the raw data of the image. The mock-PS is going to process this raw data into a level 1. Then it's going to pass it this image and any other data that it might require for fulfilling the characteristics of the Earth observation service the end user has requested. And then within the MEOS, it's going to process it further to create the complex service, just to finally, the same as before, send it to the end user. That's other use case. In the next slide. And the use case 300 is similar to the previous one, but the end user is requesting the future, well, the Earth observation service for the future, but we don't have a satellite with that characteristics available within our platform, meaning operated by our platform. But we have federated, but external, another satellite with that characteristics. So we are going to contact, this is done automatically as well. We are going to contact with this product provider, and we are going to request them to acquire the image we need. for our service. And after that, we are not going to plan it. They are going to plan it. And after they acquire that image we need, they are going to send us. And before, like the other use cases, we are going to process it into the complex health observation service, and we are going to send it to the end user. And the last use case we have defined is quite different from the previous one, because this 400 is just the request for ground segment as a service monitoring and control, meaning that here is the only one that the Earth observation end user is not requesting any service. Is the ground segment as a service end user who wants to onboard their own satellite. A new space company, as I said before, wants to use our service, our platform, to operate their satellites. It could be a constellation as well. We are prepared to do it. And they initiate the onboarding of the new satellite, of the new mission. After that, this ground segment as a service end user can operate their satellites through us, or we can use our own operators. But for example, they can plan their own images, they can schedule their own activities, and this is the automated as well. Once we have the activities they want to use, we can check the status of the satellite, we can command the satellite, we can receive the telemetry, the same as the same functionalities as like they own their own ground segment. Next, please. Well, I'm going to take over the screen. Yeah, because now I'm going to share how does it work. I'm going to focus on the use case 100 I've just explained it, meaning that the first step is that Earth observation user, a client that requires a complex Earth observation service, wants to request this service. Nowadays, we have available this list of Earth observation services. Most of them are related to agricultural information they want, like the nutritional status of a vineyard, the humidity, or as Martin said before, the closest image with or without vegetation for a specific area. These services depends on, at this moment, of a specific area of interest where you can request these services nowadays. But let's jump in. This is what the end user sees, which is the customer service web page, the client where you can connect. I'm going to connect. This is, I was signing like I was a client, an end user. Here we have the catalog browse to request a different service or my product, to see the orders I already had, the different area of interest I've just stored for whatever reason I want. Here we have defined two areas of interest where we can request some services. One is here in Ribera del Duero in Spain, where we can select different agricultural services. And the other one is here in Austria, when you can select other different services at this moment. For example, I'm going to draw my area of interest. In this case, I don't know, it should be the agricultural organization that has vineyards for this area, and I want to have some information of this vineyard. Here are the available services for this one, for this area, that it must intersect with the available area wherever. Here are the vineyard mapping time, the nutritional status, humidity status, and if we click in the information tab, we receive a description of what actually the different services actually does. Because we are planning, we are implementing this platform like the different customers, the different end users, doesn't require to know how the industry, the space industry really works. They don't really need to know beforehand where they should ask where they should go to request the different data. If they need the data from the Sentinel-2, from the Landsat Day, from any other company, a specific company, there could be dozens of company, but you don't really know which specific product is better for your needs beforehand. So we aim to have just this point of contact where different companies could federate. Different companies could supply their own data, could sell their own products, service, if you are, for example, a ground station provider. And the client, without prior knowledge of the industry, of the space industry, could come here and use this interface, easy to understand, and request whatever they need at the moment. For example, this one. It uses a time series analysis and machine learning to delimit the vineyard area. This one is quite self-explanatory, but it tells the crop humidity of the vineyard. The nutritional status, for example, gives three different products, which is the live absorption by plant pigment, the chlorophyll A and B contents, and the nitrogen contents. The biophysical status as well, it gives two different products for this one, for this service, requesting this service, this complex service. I always was talking only regarding to satellite imagery, but actually the platform can include different data coming from different sources. We don't have it implemented yet, but we are working and soon we are going to have it. Other services that we can include, for example, in situ data, the meteorological data recorded by the different antennas and machines that are in situ can be used, this data, in order to process it with other imagery and create new products, more advanced, complex, and better products. Yes, let's move and try to continue how the end user should work with this. For example, I'm going to click the nutritional status, and quite easy. Just add the service to the cart, and here we have it. We check that is the nutritional status what we want, and we go to the summary. Here, different services have different parameters you need to fulfill. In this one, we have the spatial resolution that can be high, very high, and given this, it's going to depend. This depends which satellite is going to take the images from. The beginning, the date, the start date and the end date. As I said, we are going to go through the use case 100, which is request for archive image, meaning that it's going to be in the past. That is already stored in some of the catalogs. Yeah, for example, and then we are going to proceed to order. After that, we are going to my products, and you see the new order, which is this one, but it's pending for approval. Now we did a new step, which is an operator is going to go to signing to the customer service, but the operator platform, which is not the same as the customer platform, and he's going to have the new order here, which is pending for approval. But the operator with the can is available to approve this order. And here we can check, ask the end user that it has changed from pending for approval to in progress. And the status of my product has changed to input search created. Well, I think I misclicked and I think I put a lot of time for the search, so it's going to take quite a while and it's going to be stuck. So let's just proceed to do it with less time. It was the nutritional status, I'm to cart, here hide, and let's put just 4 or 5 days. Yeah, from the 5th of April to the 9th of April, and should be better. But it's the same. We proceed. It's also pending of approval. Meanwhile, the other one is in progress. The operator sign in again and approve this order, this new order, and then on the end user page, it's going to change to in progress. Now, since we had less days, it's going to be quicker. And let me show you. If we were in the first step, the second step was once the end user requests the service and it's approved, the AMIO segment, the LEONSEGS platform, process that request and checks and sends the product search with the required characteristics we have just put on. And then it proceeds to search the specific products within the external catalogs that fulfill the characteristics. We have just passed that it was all of this is automatic, and since I put a few dates, it's going quickly through it. The next step is once the images are located, the search has been successful, the AMIO segment is going to retrieve the product that now here I can go to the processing service of the platform. One second. And we can see that it's ready, but it has not started processing the images. Now is downloading the images from the catalog. Now we are in the fourth step. This is going to take a couple of minutes. It's not. It's quite. It's all of it is automated, and it's quite quick, but it's going to take a couple of minutes just to retrieve those images. And the last step should be the processing of the complex service and the dissemination, the delivery of the product. Meanwhile, while we wait until this order is finished, I want to show you the different services we have available. Here in the Real Duero, we have this one, this set of services. But as I said, in the Austria area of interest, I can draw the same. We have other services available with other characteristics. For example, the one that Martin was talking about before, the closest matching time with vegetation. The same. We can see as well the description of each service. For example, this is the monthly or seasonal clue-free composites. This one is the nearest in type satellite imagery where vegetation is present for a chosen area. It's self-explanatory. But the process is the same as the previous one. Go to oral summary, we see the service, but there are different parameters. Closest image in time. Well, which time? Here we have the 2nd of June, but we can change it. For example, 2nd of February. Max cloud coverage. We can slide the bar from 100 to 0%. No, we can put it in the middle, more or less, 30. The minimum of vegetation coverage, we can set it as 0 as minimum. And the start date and end date of the search. Let's put a couple of months with it. And then we proceed to it. Similar to the previous, the process is the same for all the services, but it varies the inputs you have to write down, to set for the different services. And the same is pending for approval. Then the operator must go to the orders and approve the order, and it's going to change the status to in progress. And the customer service, that's what they see. In this case, it's in one step of the process, and this one is in another step. Since I don't know when it's going to finish, maybe in 1 minute or 10, let me show you how it's going to be seen after it's finished. Let's say we are in this step. Once we retrieve the images, they are going to be processed within the platform for the processing of the to the creation of the complex service. And the last step is just retrieving the final product by the end user. Here, let's take this one, which is completed. After it finishes, the status of the order goes to completed, and you can see in the is this one in the product status that is disseminated. Just clicking here, you can have information of your product, but here you can download the image directly. And yeah, that's all. Meanwhile, it's still processing the orders that we have just made. And that's the last step. Final, for example, we have the final products of the nitrogen content, like this one, or the binder map, like this one. That depends of the service you have just requested. And that's all for my part. I think you can take over again. If you have any questions, just feel free to write it down, and maybe I think at the end of the presentation, we will answer them.
Okay. Hi, my name is Johnny Marasca. I'm proposal manager at GMV. So let's switch from the technical to the exploitation. So I'm going to tell you about the future of this platform. And also, I mean, which is the strategy that we have in mind to launch into the market the LEONSEGS platform. Okay, next slide, please. So, as we said, the LEONSEGS is a federated system. It's based on an architecture, scalable architecture that is able to federate, integrate multi-Earth observation missions and multi-Earth observation data. So, which are the two pillars, as Alvaro already described? There are two. Well, the first one is the ground segment as a service. And the second one is the generation of Earth observation products, including the new ones generated by the LEONSEGS platform. Next slide, please. So I don't want to enter into details again, I mean, on the architecture, but I mean, from commercial point of view, just to tell you, I mean, which is the value proposition of our solution. So at the top, we have the ground station service providers, which represents the infrastructure layer. So LEONSEGS connects to these providers and enable the ground segment as a service model for the users. In the central layer, we see the mission operations control processing service that we call federation missions. I mean, this is very important because it integrates the mission-specific elements, so the FOS, the PDGS, or the different missions, together with the common ground segment elements. This layer is the key because it enables interoperability and the orchestration across the different missions. Missions already integrated in the LEONSEGS platform and the third-party missions you see on the right side of the slide. So there's the possibility, I mean, that external missions can be integrated into the platform, creating a federated multi-mission system. At the bottom, the platform provides that we call automated multi-mission Earth observation service, so the federation multi-mission system. This is where the real value is generated and includes the subsystems already described, in particular the multi-mission data semantic, the multi-mission product generation, and so on. Finally, from a user perspective, everything is exposed through a product request interface on the left side, you see, enabling the multi-mission data delivery in a seamless, user-oriented way. So in summary, LEONSEGS acts as an orchestrator connecting different infrastructures with different missions and services and transforming fragmented Earth observation resources into integrated, scalable, and user-driven services. Please, Olga, next slide. So these slides just summarize the main value proposition. As we said, first we provide the LEONSEGS platform provide a user-centric access to multi-mission capabilities. From the user perspective, there's also a single entry point, very easy, to request data or services, while all the complexity is completely hidden to the end users. Second, LeonSex orchestrates multiple missions as a single system. The platform also takes high-level user requests and translate them into optimized tasks across different missions based on their availability and priorities. Third, the governance. This is an important element because, the missions, so we can provide, a flexible governance models. So the missions can participate with different levels of integration, from simple data access to full orchestration, depending on the needs of the customer and the constraints. And finally, LeonSegs, as you understand, enables intelligent scalable operations with an automated service selection, data-driven planning, and efficient data processing. So overall, the platform transforms a fragmented ecosystem into a coordinated and user-driven source. Next slide, please. So let's have a look, to the timeline, so the schedule, because, okay, we have this platform and, when it will be launched into the market. So LeoSex platform, as anticipated, is approaching its end. The project, will finish in June 2026 with the delivery of the prototype LeoSex with TRL6. This is the result of a 3 years duration project supported by public funding, so through the European Commission Horizon program, combined with the consortium investments from GMB and its partners. By Q2 2028, we expect to switch from the TRL6 to TRL9. So you can understand that this is the crucial phase because here we will continue with the finalization of the developments, their integration, their testing. So it's here that we finalize the technology maturation and its industrialization. As you can see from the slide, you understand that the funding model becomes more diversified. We assume that we will continue to be supported by the European Commission Horizon program, but we start to involve strategic partners alongside internal investments from GMB. Our idea, in any case, is also to involve at least one big customer, public, institutional, or private customer. The important thing that this customer is deeply focused on the Earth observation domain in order to push him to financially sustain the finalization of the project, of the platform. After this phase, so by 2028, but probably later, before this date, we enter in the real commercial phase. So we expect an early commercial phase ending in Q2 2030, and then with the mature phase in the next years. You can see that the service in this phase is the service fully operational and scalable with a sustainable business model, largely supported by private investments of GMB and commercial returns. So just a remark regarding, the shift from CapEx to OpEx over time, because you can understand then that in the early stages, the investments are mainly capital intensive because they are focusing on the finalization of the developments infrastructure. But as the project matures, the focus moves to the operational costs. So the OpEx are higher than the CapEx so supporting the service delivery and the scaling. Please, next slide. So apparently it seems that before starting to sell the services offered by LeonSeg's platform, we have to wait for additional 2 years. But this is not completely true because our intention is to start selling preliminary services with identified early adopters customers. As anticipated, you understand that, I mean, we already identified the agriculture domain as our main early adopter. In fact, we approached some stakeholders in such field. Why? Because as demonstrated also from the demo, all the major part of the processors are already customized, tailored for to be used for the agricultural domain. That is very specific and required the knowledge of a main specific elements. But in any case, as the system evolves towards higher TRL levels, the portfolio of the segment of the services further expands to include high value domains such as environmental monitoring, disaster response, urban planning, and also the defense. This is our target market in the mid long term. Why this is important? Because after the 2030, there will be, you know better than me, I mean, the availability of the Iris2 Square. It's true that it's a telco system, but for sure the end user will need the availability of Earth observation products. So we would like, in any case, to make available our services also for this project in the future. Next slide, please. So as said, LeonSegs is a federated system. So involves the many stakeholders are involved, I mean, in this federation. These slides, I mean, shows how LeonSegs platform is presented as a two-sided ecosystem connecting supply and demand through an integrated transversal network of stakeholders. In particular, on the left side, in blue, is reported the supply chain. Which are the suppliers? We have identified two categories of suppliers, the data providers. So we are talking, I mean, the providers of the Earth observation data, commercial data vendors, satellite data owners, and the providers of the infrastructures, as anticipated by Alvaro. Our intention is not to use our antenna or ground stations. We would like, I mean, to exploit the infrastructures already available by our partners. So the infrastructure partners are, I mean, the providers that will make available for the system their antennas, their ground stations. On the right side, you can see in green the real customers, so the demand chain. We have identified two categories. The satellite operators, so the new space players that represents the core business of LeonSegs. Because don't we forget the project was conceived and takes into account the user requirements coming from the new space players. And the category of the public, institutional, and private users that they need to access you and utilize the LeonSegs services for their operational needs. As said, the platform is further enabled by an ecosystem, a transversal ecosystem of software developers, data marketplaces, system integrators. Which enhance the value proposition offered by LeonSegs by building new applications on the top of the system, integrating new services, and delivering specific end user solutions. Next slide, please. So, okay, take into account which are, I mean, the three categories of stakeholders, which are the business models that we are thinking, I mean, to adopt. So starting from the supply side, so the data providers. As we said, the role is essential in feeding the platform with their data. So from a business perspective, they operate under revenue sharing model based on data supply, licensing, and the participation in the federation layer. For what regards the infrastructure providers, these are the actors makes available their own infrastructure connectivity. Also for them, the most suitable model to be adopted is the revenue sharing, typically through the federation participation and the capacity-based fees. Moving to the demand side, and starting with the satellite operators, so the new space players, that I repeat, they represents the core business of the LEONSEGS. The most suitable model is based on direct revenues, including monthly or annual subscriptions, it depends, and usage-based fees. For the public, institutional, private users, we are thinking, to involve them through long-term contracts, including specific service level agreements, specific mission operations. But these are very important, to establish these long-term contracts because they can ensure the stability and the continuity of the revenues. Expanding on the ecosystems channels. So we said that these are mainly API users and platform developers who build applications on top of the system. So in this case, the most suitable model is something based on usage based. So driven by the API calls, the number of app subscriptions, and the data distribution. So to sum up, the model to be adopted for the supply chain is the revenue sharing. For the demand, the direct and contractual revenues, and for the ecosystem, scalable and usage-based monetization models. Next slide, please. So, as said, we already said many times that two are the pillars of LEONSEGS, so the ground segment as a service and the Earth observation products. So let's start with the ground segment as a service, which is the revenue model that we are thinking. Our idea is to start with immediately with an hybrid model, combining subscriptions with the pay-per-use models and premium services. So at the base, the basic, we can offer different tiered subscriptions, monthly or annual. So what does it mean? That the customer pay a monthly fee to access the platform with a certain amount of usage included. And this way, this guarantees to the customer predictable costs and an easy way to get started. This is, the typical approach used for new customers that are approaching for the first time in the space environment. On top of that, we can offer the pay-per-use layer. So it means that if the customer use more than what is included in their plan, so they use completely the allowances, including the subscription, they simply pay extra based on the usage. An extra fee, for example, per pass, counted per data volume or per processing. And this allows them to scale flexibly as their needs grow. For larger institutional users, we can also offer a premium layer with service level agreements based contracts, including features like reserved capacity and guaranteed services. So you understand that, these are premium services, so they are much more, expensive, but they are regulated, and also regulated by long-term agreements. Don't we forget that, everything works because on background, your model is enabled by the ground stations, the infrastructures provided by our partners. So the infrastructure partners participate to this federated approach, so they are part of a revenue sharing model. Next slide, please. So here, I just prepared this slide just to show you which are the main cost drivers of the ground segment as a service. This is just a scenario based on a typical SAR constellation. So, for example, let's assume that the customer needs to get the service, the ground segment as a service, from a constellation of 4 satellites with passes per satellite for 6 per day, for example, a contact duration of 10 minutes. We have to, considering these assumptions, so we have to define the final price. So which are the elements to take into account? The antenna time, the compute resources, the storage of the data, and the data transfer. So in this example, for example, if the customer needs the specific constellation, the service for the specific constellation for a month, we calculate that 6,000 minutes per month are exactly the antenna time, so the reserved antenna time for the customer. For example, 3,000 are the hours per month requested for the computer resources, 5 terabytes per month for the storage, and so on. So all these for all these parameters properly combined will define the final price for the customer. Next slide, please. Okay, for what regards the second pillar, so the Earth observation products. Yeah, the model is a bit complex, as you can understand, because there are many parameters to take into account. So in order to understand which is the pricing logic behind, let's start from the very beginning. Let's start from the customer request. So the customer submit a request to the platform. This request can be, for example, monitoring a specific area. At this point, the platform, being federated, does not rely on a single source, as demonstrated, but combines data from multiple providers and multiple missions. So the platform selects the most suitable data and processes it to generate an Earth observation product. So you can understand that the product is not standard, but built based on the specific customer request. And so also the pricing is very structured and scalable. So as you can see on the bottom on the slide, you see, the main 4 factors then properly combined, define the final price. So we have the area, so the extension to be covered, the time dimension, meaning the frequency and the duration, the complexity. If we have to include artificial intelligence, algorithms, or machine learning, or, for example, multi-sensor data, and the SLA. So how fast and with what priority the service must be delivered, so the QoS. All these factors, parameters, lead to a layered offering because simple requests result in standard monitoring services. More complex needs lead to advanced monitoring. You see, this pyramid. Most advanced cases provides artificial intelligence-based insights and decision support. So the logic is the customer makes requests, the platform aggregates and processes data, a tailored Earth observation product is generated, and pricing is directly linked to the level of the service required. So the next slide, please. So this slide, represents just an example of Earth observation products. So, we started to say that okay, we already identified this early adopter, so we already try to define a sort of catalog of services for specific for the agriculture segment. But which is the pricing logic behind this specific use case? On the left side, you see, the list of these parameters. So they are very relevant for the agriculture domain. For example, the type of crop, that is very important to know. The area covered, since the services are often priced per hectare. Then we have the service type, because the customer can request, for example, basic monitoring or more advanced predictive services. The data source, if it's public or commercial, the frequency of monitoring, so depending on how often the fields need to be observed, and the level of the complexity in terms of machine learning, artificial intelligence, algorithms, and so on. So all these parameters together are translated into a structured pricing model, reported here on the right side of the slide, where you can see, the core of the model. The core of the model is represented by the subscription, monthly, annual subscription, including a such amount of allowance of services. So we pay, we offer a service based on euros per hectare per month or per year. And this represents the real baseline revenue. On top of that, we can offer some customization, some changes. For example, if the customer requests the monitoring area for 2-3 years, we can think to increase, to offer a solution with higher cost in the first year due to the SAP integration, but then with a lower recurring cost in the following years. Or, for example, we can apply a scaling effect because the customer could increase the area to be monitored. So in this case, the price per hectare decreases as the monitored area increases. And finally, we can also, provide add-ons. So additional data, additional processing, additional customer requests. So with a pay-per-use model, so extra fees. This is in general just to tell you that it's very complex to elaborate a catalog of service of the Earth observation products because it depends which is the market segment. So next slide, please. Okay, so just to ending my intervention. The idea, as you can understand, is we're approaching the end of the project. We start, with the future exploitation of our platform. We already started, to approach partners. In case you are interested, we can arrange one-to-one call. We can provide you insights on particular aspects, staff domains in which you are interested, just to understand if it's, the case, to fight for a collaboration and which are the mutual expectations. So, it's very open. It's up to you. Okay, that's all for me. I leave the floor to Catherine.
Yeah, thank you, Gianni. My name is Katrin Lunzner, and I will present an overview about follow-up resources to complement today's workshop. From university side, we have developed 2 follow-up resources where you can explore the LEONSEGS platform in more detail. The first resource is the LEONSEGS webinar, and it complements this workshop with a self-paced, guided, and interactive walkthrough and explain the LEONSEGS concept in more detail. So the webinar covers chapters like a compact overview of the system architecture and how the main platform components work together. Or another example is end-to-end demonstration workflows with a walkthrough from defining a request to receiving the delivered Earth observation product. And additional in the webinar, you can also find more use cases to discover more of the platform capabilities. And we also have included a detailed chapter with more explanation of the semantic search and retrieval and how it is implemented into the system architecture. So altogether, the webinar is a continuous project resource. That means it will be updated with new project developments, further demonstration materials, and also the workshop recording will be included. Yeah, and the second follow-up resource developed from our side will be a MOOC. The MOOC is currently in preparation and will be built on the webinar as an extended interactive learning resource. And the MOOC will offer more structured models and additional background and material to explore the LEONSEGS concept in a more depth. Yeah, to access the webinar, you can directly scan here the QR code. It's a mobile-friendly version also, and we have the link also on the project website. Also, the MOOC will be made available very soon on the project website. So next slide, please. Yeah, we also offer a survey and we would like to invite you to complete a user validation survey. The survey gives you the opportunity to tell us what matters most from a user perspective. And it's a quick survey and it focuses on topics like where the platform could be improved or developed further, or where relevant future requirements are, or for example, which demonstrated workflows are most useful or relevant from a user perspective. Yeah, to access the survey, you can also scan the QR code. It's also available on our website, and the survey is already open and can be accessed anytime. Yeah, so after the workshop, we will also send you a reminder with all relevant links and also the survey again. So a request from our side is that to please complete the survey by May 15th. So we can include it in our user validation analysis, the responses from your side.
As Johnny mentioned, let's all stay connected. The project is currently open to different kind of collaborations and partnerships. We want feedback from potential users. So follow us on the social media as well. Take a look at the survey sent to you. We will also do a follow-up and send you all those resources for you to look at them again. And thank you so much for the attention and for participating in today's workshop.